Now here the question is, consider an ellipse and a concentric circle. The circle passes through focus of ellipse and intersects the ellipse in 4 distinct points. The length of major axis of ellipse is 15 units, and if S1 and S2 are focus of ellipse and area of triangle PS1S2 is 26 square units, then eccentricity of ellipse is equal to which of the following value? Now we are given an ellipse and a concentric circle, and circle passes through focus of this ellipse. So we'll draw this ellipse. And suppose center is C. Now we have a circle which is concentric to this ellipse. And which passes through focus of ellipse, say S1 and S2. Now it intersects this ellipse at 4 points. Now suppose one of the point of intersection is P. So it is given that length of major axis of this ellipse is 15 units. So that means 2a, it is equal to 15. And area of this triangle PS1S2 is 26 square units. So area of this triangle, it is 26 square units. Now we know that this point P, it lies on ellipse, so it will satisfy its focal property. So from here we'll write PS1 plus PS2, and it must be equal to 2a, and 2a in this case is 15. Now since S1, S2 is diameter and this point P, it lies on circle, so that means this angle is 90 degrees. So area of this triangle simply will be half base into altitude. So we write 1 by 2 PS1 into PS2, and this value, it must be 26. So from here we write PS1 into PS2, and this value, it must be equal to 52. Now we'll take PS1 as say X and PS2 as Y. So we'll get two equations which are value of X plus Y is 15 and X into Y is simply 52. Now we can write X minus Y. So X minus Y square will be X plus Y square minus 4XY. So we'll write X minus Y square as X plus Y square, which is 225 minus 4XY. So it'll be 208. So from here we'll write X minus Y as plus or minus under root 17. Now we'll add them. We'll get this X as 15 plus minus under root 17 by 2, and we'll subtract. We'll get Y as 15 minus plus under root 17 by 2. So it simply means focal radius, one of them must be 15 plus under root 17 by 2. Say this is PS1, and the other one should be 15 minus under root 17 by 2. Now we need to find eccentricity for this ellipse. So for this right angle triangle, what we can write is, we can write S1 S2 square, and this is equal to P S1 square plus P S2 square. So we'll square and add. We can write this as 225 plus 17 upon 4 into 2. So it'll be S1 S2 whole square, and this value is equal to, now 225 plus 17, so it'll be 242, and 242 divided by 2 is 121. So from here we'll write S1 into S2 is simply 11. So S1 S2 is distance between focus, which is 2AE, and 2AE is 11 and 2A is simply 15. So value of E is simply 11 by 15, and that's your option number D.